I hope you still remember we covered some information about the working essays in the ER model, right? Because in the real world, some of these entities may depend on some other entities. And we also show you with some examples before, right? So again, let's assume we have some employees. This employee may create some policies in some company, right? Like insurance policy, and they may also claim some person to be his or her dependents. The employee has a bunch of attributes: SSN, name, and not. And the policy has one attribute, the cost. The dependents has a name as well as age information. Before we mentioned that this dependence, this entity can be so weak, and its key must come from some other entities it depends on, right? If we want to identify one dependence, we need to combine both the SSN together with the PNAME. It will form a key for the dependence, right? Because this one is a working asset. Then how can we do the translation for such working assets? We can provide the translation rules. Okay, so we have the example showing this page, and we can create the relations for them. Let me copy this one here. And we have the relation created for the employees, right? This is what we have before. Here, let's assume we first treat this working assets as a very normal entity set, and we also treat this policy as a normal relationship. So we can represent this dependence as a relation, right? We have dependence. It has a P name, right? Also the age is an int, right? And besides this, we also have the policy as a relation, right? Its key will be SSN, right? Its another key will be P name, right? For example, we also assume it is 9, and we have a cost is real. If we treat them all as regular entities and relations, and we can do the translation in this way, right? Here we need to pay attention to the dependence. We claim that the P name is not enough to serve as its key. We have to borrow the key from from the entities it depends on, right? I mean the employee it depends on. In other words, for the dependence, since this one is weak, and we have to add this SSN as another attribute inside this relation, right? Because it depends on this one. We have to combine the SSN and PNAME together, which will serve as a key for dependence. Therefore, for the translation of dependence, there will be some differences. We have to add this SSN as another attribute for it, right? So SSN combined with the PNAME will serve as a key for dependence. And for the policy, its key will be the SSN combined with the PNAME, right? We're going to underline here and underline here. Then you will be able to find a problem, right? For the dependence, this is relation as well as the policy relation. Its key are both SSN and PNAME, right? They have the same keys. In other words, for their table, the table dimension, the number of rows will be the same. If we store the data in this way, then we have to store the SSN PNAME twice in two tables. It will create lots of redundancy and also waste lots of space in the storage, right? And therefore, we may wonder if we can combine these two together, right? We can create a new relation instead by combining them together. We can do so, right? In this way, it can reduce the redundancy and also save the storage space greatly. We want to combine them together by creating a new relation. We can create a new relation and bind them it as a policy dependent, right? Its attribute will be combine all the attributes together: SSN, PNAME, cost, and age. Right? So in this way, we will do the translation of this ER diagram into relations. The first relation we have is here, right? It will be a relation for the employees. The second relation we will have will be the policy dependence, right? it's another relation we can create. Therefore, you can see when we are handling these weak entities, the translation rules will be different from the normal case for entities and relationships, right? We need to combine its policy relationship with the dependencies and entities together in the translation. So this is what you need to pay attention to when you're doing the homeworks. If we are doing the translation of these working entities, we probably need to have a combination of two relations into one instead. And in this page, we also show you how to create a table for the dependency policy, this relation we showed before. Even the name is different from what we show in the example, right? However, the attributes as well as the information, they are all the same. We have a P name, age, cost, and SSN as attributes. So the primary key for this relation or the table will be a P name combined with SSN. We know SSN is a key we borrowed from other tables. Therefore, we have to use this foreign key as a reference to the employees table. And at the bottom, we have something new on delete cascade. It means if we delete this SSN in the employees table, we will also delete the corresponding rows in the dependent policy table as well. In this way, we will guarantee we can always refer to some entities which exist in the tables. Right? This is used to maintain the referential integrity constraint in the working entities. We will also show you more on these actions once we do some updates on some foreign keys. Besides on the delete cascade, we can also have some other options to be added here. We will show later. So you just need to remember when we do the translation with working entities, we need to combine the relation with the working entity together to form a new relation, right? As well, when we define the tables for it, we need to claim the primary key as well as the foreign key. And at the end, you can add this on delete cascade to maintain the referential integrity constraint.